Hello everyone. Welcome to Learning Management System, Department of Collegiate and Technical Education. Myself, Sridhar Murthy, Selection Grade Lecturer, Department of Electrical and Electronics Engineering, Government Polytechnic, Chikmagalur. In today's session, we are going to learn about Introduction to Alternators of session 27 belongs to DC machines and alternator subject of third semester. So this session comes under Unit 4. Let us recall what we have learned in the uh, session number 26. So in previous session, we learned uh, construction of a three-point starter and working of three-point starter in DC motors. So in this session, we have discussed what is the necessity of a starter for a DC motor, and what are the different parts of a three-point starter, and how the starter will protect the DC motor against starting heavy inrush current, and how overload relay works, and how the no volt coil will works. So these are the things that we have discussed in the previous session. So in today's session, we are going to learn mainly about what is an alternator and some of the important points relating to the alternator, and also the basic difference between an alternator and a DC generator. So in this session, we mainly concentrate on introduction to the alternators. So first, we will see what is the definition of an alternator and important points regarding the alternator, and the major difference between a DC generator and an alternator. Remember, we already discussed about the DC generator unit 1 and 4. So this is unit 4. We are discussing about the alternator. Let us see the definition of an alternator. So basically, similar how we are going to define about a DC generator. Try to recall the definition of a DC generator. A DC generator is a electromechanical device that converts mechanical energy into electrical energy in the form of DC. Similarly, alternator is also generating or is also converting one form of energy into another form of energy. Like DC generator, an alternator is also defined as an electromechanical device that converts mechanical energy into electrical energy in the form of alternating current. So let us consider an alternator which takes mechanical energy at the input and gives out electrical energy at the output. And remember, this electrical energy is in the form of AC and not DC. If it is a DC, that is the definition of a DC generator. And here, this electrical energy is in the form of AC. So this is the basic definition of an alternator. Let us see the precise definition of an alternator. Alternator is an electromechanical device that converts mechanical energy into electrical energy, that is in the form of alternating current. So this is the definition of what is an alternator. In simple, an alternator is a big energy converting device. It takes mechanical energy at the input and gives out electrical energy at the output. So after seeing the definition of an alternator, let us see some of the important points regarding the alternator. The very first point is, so who suggested the alternator? Basically, the alternator, the alternator is suggested, the concept of alternator is suggested by Michael Faraday and the Hippolyte Pixie. So these are the two great men who suggested the very first concept of alternator. Yeah. So here also we cannot forget the contribution given by Nikola Tesla. So he also the person who suggested the concept of the alternating current. So in general, in particular, the two great persons who suggested the alternator are the Michael Faraday and Hippolyte Pixie. So these are the two great men who suggested the alternator, the concept of alternator. Next. So in our previous semester, we learned what are the major advantages of AC system over DC system in our lower semester, that is in first semester and second semester. See, here I am going to highlight what is the major important advantage of AC system. The major advantage of AC system over DC system is that we can rise or decrease the level of the voltage as per our requirement in case of AC system. But this facility is not available in DC system. So because of this major advantage, AC system is much more popular than a DC system. Remember, we don't have the transformer facility in case of a DC system. That is the major drawback of DC system, that we cannot use for generation and transmission and distribution in large. Okay. So the next point is, that is the reason why, because of the point number 2, so hence AC system is extensively used for the generation, transmission, and distribution. Next. Alternators are also called as AC generators or synchronous generators. The reason behind this is the alternators has to rotate at a particular speed given by the formula Ns is equal to 120 F by P. So the alternator must run at this speed given by this formula, because the alternator has to produce a voltage or an EMF at a particular frequency. So in order to produce the voltage or EMF at that particular frequency, the alternator must run at a particular speed given by the formula Ns is equal to 120 F by P. In this formula, whereas Ns is called as the synchronous speed, F is called as the frequency, and the P is called as the number of poles. Okay. So because of this, so we have to rotate the alternator at this particular speed. Hence, alternators are also called as synchronous generators. Very simple. Why? Why? Because the alternators are rotating at a synchronous speed. See here, the mechanical energy is usually supplied by the steam turbines or gas turbines and combustion engines. So we need mechanical energy, because as per the definition of an alternator, alternator converts mechanical energy into electrical energy. So who is going to supply that mechanical energy? That mechanical energy at the input of the alternator is supplied by the steam turbines or by the gas turbines, or in simple, some combustion engines. Next, an alternator that uses a permanent magnet. Suppose in case of alternators, we use the magnetic system with the help of a permanent magnets, then the alternator is called as a magneto. Remember, alternator can be also called as a synchronous generator, because it has to run at a particular speed called as synchronous speed. Hence, it is called as a synchronous generator. Similarly, if we use the permanent magnet for producing the magnetic field, then it is called as, the alternator is called as a magneto. Next point. It also works on the same principle as that of the DC generator, that is Faraday's laws of electromagnetic induction. So as we know that the the basic principle of working of DC generator is the Faraday's laws of electromagnetic induction. Similarly, an alternator will also works on the basic principles of Faraday's laws of electromagnetic induction. So try to recall this law, what we have discussed or what we have learned in the unit 1 and 2, that is the principle of operation of DC generator, the electromagnetic induction, that is whenever the flux linking with the conductor changes, an EMF will be induced in the conductor. So this is the basic principle on which both the DC generator as well as alternator will work. But in our future sessions, in our future slides, we are going to see what is the because both alternators and DC generators are works on the same principle. Then what is the difference? The difference will be seen in the next slides. Then the next point is, like DC generator, alternator must also has an armature and a field system. So like DC generator, armature should also consist of conductors and the magnetic system, because both the DC generator and alternator works on the same Faraday's laws of electromagnetic induction. Hence, there must be a conductor in both the cases, and there must be a magnetic field in both the cases. Okay. Next, but the most important point in alternator is that instead of split rings, here we are using strip rings. That is, the alternator will not have the commutator. Commutator or split rings are not used in case of an alternator. In case of an alternator, we use only slip rings. Because in case of a DC generator, the induced voltage is AC in the armature conductors. So because it is a DC generator, we have to convert that induced AC into DC. But here we are studying alternator or AC, we need AC, hence no need of commutator. Hence alternator is not having the commutator, one of the important point of alternator. Next one is in case of a DC generator. See, this point is another most important point as the previous one. That is, in case of a DC generator, armature rotates, but the field system is stationary. So this important point is very important in case of an alternator. That is, in case of a DC generator, the armature will rotate. That means the conductor will rotate. But in case of a AC system, alternator, the armature or the conductors are stationary. And in case of a DC generator, the field system is stationary. But in case of an alternator, the field system is rotating. So this important point is must be noted. Next. As I told you, but in case of an alternator, field system is rotating and the armature is stationary. Hence, the field is called as rotor because the field system is rotating. The rotating part is called as the rotor. And the armature conductors are stationary in case of an alternator. Hence, the stationary part is called as stator. Okay. Hence, in case of an alternator, the armature is the place where the conductors are placed or the winding is placed, which is a stationary. Hence, in case of an alternator, the armature is also called as a stator. Remember, the rotor is rotating. Hence, the field system is rotating. Hence, it is called as a rotor. Next point. So we need DC excitation. Very simple concept. Because in case of a AC, we need in case of an alternator, we need magnetic system for producing the EMF. Hence, in order to produce that magnetic system, we need an excitation, and that excitation is nothing but a DC excitation. Yeah, the system which provides this DC excitation is called as exciter. Usually, in case of an alternator, compound generators or in simple shunt generator, DC shunt generator are used for exciting the field system. Okay. Next point is in both DC generator and AC generator. Remember, in both DC generator and AC generator, the induced EMF in the armature conductor is AC only. Remember, dear students, whether it is a DC generator or AC generator or an alternator, the induced voltage in armature is always AC. If you want DC, you have to use the commutator. If you want AC, don't use the commutator, just use the slip rings or just collect the induced voltage in the stator straight away. Next one is alternators may be single phase or it may be a three-phase machine. Okay. So alternators are in simple, the types of alternators are nothing but the single phase alternator or three-phase alternators. So if you see in particular the types of AC generators, we have induction generators are also, we have synchronous generators also. Okay. After seeing the many important points regarding the alternator, let us see some of the important differences between alternator and DC generator. How alternator is different from DC generator, or how DC generator is different from alternator, that will be seen in these slides. Let us take this table. This table will clearly differentiate between AC generator and DC generator in terms of some particular properties. Okay, let us see the first differentiating property, definition. Regarding the definition, both AC generator as well as a DC generator, we have different definitions. Initially, the definition seems to be same, but the single point will make the difference between AC generator and DC generator. What is that a single point which will makes the definition of alternator and DC generator different? Let us see. So as I told you, AC generator is a electromechanical device. AC generator is a electromechanical device which will convert some mechanical energy into AC, that is a AC electrical energy in the form of AC. Okay. Here it is called electromechanical device. Why? Because remember students, both AC generator and DC generator both are called as electromechanical device. Why it is called as electromechanical device? See, both the machines takes mechanical energy and converts it into electrical energy. So hence the device is called as a electromechanical device. But in case of an alternator, it produces electrical energy in the form of AC. In DC generator, electrical energy is in the form of a DC. So that is the single point which will differentiate AC generator and DC generator. So this AC and DC will make the difference. The second difference is the direction of the current. So as I told you, in case of an AC generator, as the name implies, the induced voltage or the current is alternating in nature. But in case of a DC, the induced voltage or the current is always unidirectional one. That is, it is having a constant or fixed direction. Next, the third one is, it is in terms of basic design. In terms of basic design, so in case of an AC generator, as we have seen in the previous slides, so in case of an AC generator, the conductors or the armature is a stationary one and the field is a rotating one. In case of an alternator, the armature or the conductors are stationary. Hence, called as stator, those conductors are stationary. But the field system or the magnet is a rotating one in case of an AC generator. But in case of a DC generator, the conductors or the armature are rotating, whereas the field system is constant. So this is the difference between AC generator and DC generator in terms of basic design. So in this slide, we have seen the difference of alternator and DC generator in terms of definition, in terms of direction of the current, and in terms of basic design. Yeah. Next, the next difference is the commutator. Or we are using commutator in AC generator? No, no need of commutator. Why? Because you need commutator if you want to convert the induced AC in the armature conductors to DC. Then you need commutator. But in case of an alternator, we need AC. So hence no need of commutator. But in case of a DC generator, no need of slip rings. So here we need DC only. Hence we need commutator, which are also called as the split rings. Okay. So the fifth difference is that is the one rings. So in AC generators, we need slip rings. So slip rings are used to supply DC excitation to the magnetic system. Whereas in case of a DC generator, we are using split rings, are also called as the commutator, to convert induced AC into DC. The sixth difference is efficiency of the brushes or the slip rings. So in case of AC generator, only 2 slip rings are used. So hence they have a smooth surface and uninterrupted surface. So they do not wear quickly as compared to the commutator. Hence the efficiency of the slip rings and brushes are more in case of AC generator. And that is another point is that we don't have commutation in AC generator. Okay, that is the biggest difference. Whereas in case of a DC generator, coming here, both brushes and commutators of a DC generator will wear out quickly and hence it has a less efficiency. It is because of the commutation. Because of huge sparking across the brushes, both the brushes and commutator surface will wear out very quickly. Hence, automatically, the efficiency of the brushes and split rings or the commutator is less in case of a DC generator. So in this slide, we have seen the difference between the AC generator and the DC generator in terms of the commutator, slip rings or the split rings, and the efficiency of the brushes. The next difference is Which are the rotating parts? Regarding the rotating parts, so in case of an alternator, the rotating part of in alternator is a low current and high resistivity motor. So that means, so we need a low current, that is a DC excitation only. So we need current to produce magnetic flux only. So hence we are having a low current and low voltage is sufficient. Hence the rotating part in case of an alternator is having a very low current and high resistivity rotor. But whereas in case of a DC generator, which is the rotating part? The rotating part in case of a DC generator is armature, that is the conductor, which is a huge heavy mass. So hence the rotating part is a complicated one in case of a DC generator. So this is regarding the rotating part. Next, regarding the output voltages, in case of an AC generator, the output voltage is varies with respect to the is varies in terms of amplitude with respect to the time. That means its amplitude, the output voltage or current amplitude is not fixed with the time. It is varying with respect to the time. Hence, output frequency is varies between 50 to 60 hertz because the nature of the alternating current is like that only. But in case of a DC generator, the output voltage magnitude or the amplitude is fixed. Both, that means in case of a DC, the direction is fixed with respect to the time. Okay, its amplitude is also fixed with respect to the time. So that is that is the difference between AC generator and DC generator with respect to the output voltage. Now coming to the difference between the AC generator and DC generator in terms of maintenance. Obviously, because of the commutation and because of the sparking across the brushes and commutator segments, so the maintenance of a DC generator is much more and hence it is less reliable. Whereas in case of AC generator, those problems will not be there. Hence, the maintenance of AC generator is less and we can, the reliability of alternator is also high. That is regarding the maintenance. Next, coming to the types, as I told you, the alternator is of single phase type or of three phase type, or it may be a induction generator or it may be a synchronous generator. So that's all the difference, the different types of alternators. But coming to the different types of DC generator, there it may be a permanent magnet generator or it may be a separately excited generator. It may be a permanent magnet DC generator or it may be a electromagnet DC generator. The electromagnet DC generators are further classified as it may be a separately excited or it may be a self-excited. Self-excited, in case of self-excited, depending upon how the field winding is connected with the armature, it is further classified as series generator, shunt generator, or compound generator. These things we have already discussed or learned in unit 1 and 2. Okay, so this is the difference between the alternator and DC generator in terms of output voltage, maintenance, and times. The next one. Regarding the cost wise, the initial cost of the AC generator is high because the alternator are we are producing the voltage at a very large scale. So hence initial cost of the alternator is very high, but remember running costs are less compared to the DC generator. In case of a DC generator, the initial cost of the DC generator is less, but the running cost of the DC generator is large because of the maintenance of the commutator and the brushes. Okay. The second one is, next point is the distribution and the transmission. The output of the AC generator is easily distributed by using a transformer. So in the very beginning slides, we have learned why AC is much popular than DC. It is because of the transformer. The transformer will make a big issue why the AC is much popular than DC. Okay, so based on that concept, distribution and transmission, the output from AC generator is easy to distribute using a transformer. But whereas in case of a DC, we don't have the facility of transformer. Hence, the DC voltage produced by a DC generator is very difficult to distribute and transmit because we don't have transformer. Next difference is the efficiency. Alternators are very efficient because of less losses. Why? Because so we don't have the sparking across the brushes. So obviously efficiency will be large. Whereas in case of a DC generator, less efficiency because of the sparking. Next, regarding the application wise, the alternator. So as we all know, we are much depending on the AC system. Hence, obviously, the application of alternator is much more than that of the DC generator. So these are the some of the important differences between DC and AC generators. So students, till now we have discussed or we have learned the basic definition of the alternator, some of the important points regarding the alternator, and majorly what are the difference between an alternator and a DC generator. So in this session, we are going to learn some of the multiple choice questions. So let us see the first one. Based on this today's learned sessions, the MCQs are made. The first one is alternator converts. So what are the options? Electrical energy into mechanical energy. Second option is mechanical energy into electrical energy. The next one is mechanical energy to mechanical energy. And the last option is electrical energy to electrical energy. Okay. So which is the option? So the answer is, as per the definition of an alternator, alternator converts mechanical energy into electrical energy. So answer B is the right one. See the answer? Answer B, mechanical energy to electrical energy. So this is the first multiple choice question. The next one is, the very first concept of alternator was suggested by? Who suggested the first concept of alternator? Let us see the options. Michael Faraday, Alexander Flemings, Hippolyte Pixie, or Michael Faraday and Hippolyte Pixie that we have learned? The answer is Michael Faraday and Hippolyte Pixie. The next question is, alternator works on, what is the principle? Principle of working of alternator. Faraday's laws of electromagnetic induction, Ohm's law, Lenz's law, or the Fleming's law. So both alternators and DC generators works on the basic principles of Faraday's laws of electromagnetic induction. So answer A is the right one, Faraday's laws of electromagnetic induction. The next MCQ, in both DC generator and DC generator, the induced EMF in the alternator conductor is, that means in both alternator and DC generator, what is the type of induced EMF in the armature conductors? The options are AC to AC and DC. Is it is the both one, or DC only, or AC only, or none of the above? See, whether it is a DC generator or AC generator, the induced EMF in the armature conductor is always AC. If you want a DC, you have to use the commutator. If you want to AC, let it, no need of commutator. Take the induced AC as it is to the outside. Hence, the answer is, answer C is the right one. That is AC only. The next MCQ, in alternators, the moving part. So in alternators, the moving part, which is the moving part of the alternator? I have highlighted that important difference in whilst learning the difference between alternator and DC generator. So which is the moving part? The brushes, poles, armature, commutator, which one? Poles are the moving. That is, the magnetic system is a moving one. The magnetic system is moving, hence it is called as a rotor. Magnetic system is nothing but poles. Instead of poles, the option may be also the magnetic system. So magnetic system is the rotating part. Magnetic system is nothing but the poles. Hence answer B is the right one. The next one is the voltage applied to the field of the alternator. So what type of voltage we are going to apply to the field of an alternator? So in order to produce the magnetic flux, what type of voltage we need? We need AC only, the first option. Second option, it may be a AC or DC. it may be DC only or high AC. Which is the answer? So remember, students, see, if we apply AC to the field of the alternator, definitely the magnetic field will be produced. But what type of magnetic field will be produced? The alternating magnetic field will be produced. Sometimes North Pole, sometimes South Pole. That means the direction of the poles is continuously changing. So obviously our purpose will not be served. Suppose instead of AC, if we give DC, it produces a constant uniform magnetic flux. So hence, which is the answer? Answer is DC only. So these are the some of the MCQs. So dear students, today we have learned the definition of the alternator, the important points regarding the alternators, the major difference between alternator and DC generator, and we learned many MCQs. So uh, these are the uh, sessions, these are the points that we have discussed in this session. So for this today's session, the reference material is, these are the ones, and that is the end of the session. Thank you, dear students. Thank you, one and all.